Hello and welcome back to the class of 5G. In previous lecture, we took a brief look at the intents behind 3G. Now it's time to shift to the actions. Let's go in the typical problem-solving manner. We have already discussed multiple access previously. It was an efficient way to serve multiple customers using same band of frequencies. We used to share the spectrum by means of time slots and by means of frequencies. Now the question is, if the intent is all about increasing the customer base and growing the business, it is quite likely that you will have more or evolving number of users under the same base station. And if the number keeps on growing, we may run out of spectrum. So, what to do? Arguably, you can say that we can just increase the number of cells, which means we can make the cellular network denser by making the range of the cells smaller and increasing the number of total base stations or total transmission towers. That would mean that even if the number of customers grew, the spectrum would be shared within same or less amount of people. But there's an issue, and it is called the handoff. For the part of audience who are already students of electronic communication, you might be wondering, why hadn't we spoken of handoffs when we were discussing 2G? Because handoffs play a significant role in this discussion. So we were never going to ditch it, but it makes more sense to cover it right now. Let's get further. To understand handoffs properly, we need to take a look at something which we were taking for granted for a while now, which is, how does the call get connected? This may seem like one of the most primary things to learn, but if we had taken that route and piled your head up with a lot of theories, you would have lost the interest in the topic. So, it is better to learn the topic when its importance comes into the picture. Let's get started. Let's say we have a cell tower, also known as a base station, and we have a mobile phone user who is within the range of the base station or the cell tower. To perform the action of something known as connecting the call, the user first of all sends a request control signal through their cell phone. These request control signals are received by the base station or the cell tower antennas, and they are verified. Once they are verified, these signals are processed. The request signal includes important details of caller and receiver ends. So once the signal is verified, the tower is ready to send the request to either the receiving user himself or to another tower or base station where the receiver is located. If the receiver is found available, the cell tower sends a confirmation signal to the mobile phone user. By the way, if the receiver is not found available, that becomes a different case and we receive a different kind of confirmation signal, which you might recognize as one of the tunes which play during the receiver of your call is busy. It sounds something like this.
The person you are trying to call is currently busy.
And that's how the call connection process works. But we can never assume that the users are going to remain stationary, which means that either the caller himself or the receiver might change their places during their on-call as well. And while doing so, they may switch the cells, which means that they may shift their location from one cell to another. We have already seen that when we switch the cells, the adjacent cells never share the same frequency. The frequency needs to be allocated again, it needs to be reconfigured, the user data needs to be sent to the adjacent cell, and adjacent cell needs to make sure that it has enough resources to keep the call process continued. Because by no means can any telecom company afford to have its users face call terminations when they are switching the cells. So this smooth transition from one cell to the adjacent cell is called handoff. The name itself is quite suitable. The base station of one cell hands off the information of the call to the base station of another cell, and the new or the adjacent cell takes care of the call to make sure user has a satisfactory experience. If we take this phenomenon into consideration for the solution we had proposed earlier, which was all about making the cellular network more dense and increasing the number of cells, it would also mean that we would increase the number of handoffs, and that is a problem. You might be wondering, if handoff is a smooth process, why is it a problem? The thing is, handoff is not just about sharing the frequencies. The verification of the user, verification of the location, which means whether the user is still in the local area or is he in the roaming state, maintaining the security, allocation of the frequency, everything is computation intense as well. It just complicates the network even more, which can bring more delays, more latencies, and potentially more call terminations. So, growing the number of cells, at least at this point of time, is not the best solution. You can say that growing the cells was a rejected solution, which means it didn't work out. In the next lecture, we will talk about a solution which did work out. Till then, happy learning, and as always, I hope you have a fantastic day.